Lesson 2.3, real zeros of a polynomial function. What we should learn. We're going to learn how to use long division to divide polynomial functions. We're going to learn how to use synthetic division to divide polynomial functions, a shortcut. We'll learn how to use the remainder factor theorems, and we'll use the rational zero test to determine possible rational zeros of a polynomial function. So we're going to do all that in this lesson. So, long division. Long division of polynomials, honestly, works the same thing as long division like you did in grade school. It's like a little quick reminder. Let's say we want to divide, I'm just going to make this up, 541 by 3. Okay, I'm making sure that's divided by 3 in my head. So, what do we do? Step 1, right, we kind of look at the first number and the number there, and we go, how many times does 3 go into 5? In this case, 1 time. And then we multiply. 1 times 3 is 3. And then we subtract, right? So we're going to multiply and subtract. That, and then we're going to bring down. I'm writing this so that it's a reminder. Right, we bring down the next number, that's 4. And then you go, how many times does 3 go to 24? In this case, it actually worked out nicely. It's 8. Didn't plan for that. And then we subtract, we get 0. We bring down the next one, 1. Like, how many times does 3 go into 1? It doesn't, so it's a 0. So times 3 is 0. We subtract, and you get a remainder of 1. Now, remainder one's like how you did in grade school. Technically, what you're supposed to be doing is put that guy over the thing you divided by. So this should be 180 and 1/3. Right, so that is 541 divided by 3. 180 is remainder 1, or 180 and 1/3. That's long division. When we do long division of polynomials, it's the exact same process. So we're going to do the exact same thing. I get a little long, but we'll see. 6x cubed minus 19x squared plus 16x minus 4 divided by x minus 2. So we're going to do the exact same process. So we're going to start off the same. Okay, you look at the first term only and this term right there. Right? I don't care about this guy right here at all. You just care about the first term. That's our whole focus. And you go, what then multiply x by to get 6x cubed? And you should be like 6x squared. Right? It's an x, it needs a 6, so you multiply by 6. It is an x, it needs 2 more x's to get x cubed, so 6x squared. And then we're going to multiply, the next step. So right, first step is like, look, how many does it go in? And the second step is we multiply. So we'll multiply the 6x squared by x minus 2, by both of them. We're going to multiply this by both of these, so we're going to distribute. And get 6x cubed minus 12x squared. I showed it up here just so you can see where I get the numbers from. So that's what I'm going to do next. This guy multiplied by both of these. So 6x cubed minus 6x squared. Right, so we multiplied. What do we do next? Subtract. So we got to go this guy minus this guy. Now a lot of people make a mistake here. So where the most common mistake is right here. So what I like to do is put a little parentheses and then put a minus sign. And then I'm going to go beyond that. I distribute myself. So it makes it negative 6x cubed plus 6x squared. Then I just add, because I distribute it, because add. These cancel out. Negative 19x squared plus 6x squared is 13. I can do math sometimes. Minus 13x squared. Right? To me, it's a lot easier than like trying to subtract. I just like distribute. I put a minus sign, put parentheses, distribute, and then add them down. So I get this. What's next? Bring down the next term. Right, and then I forgot to put here is we repeat the process. That's all we're doing. We're going to do the exact same thing here. So I'm going to repeat the process. I'm going to look at the first ones again. I just look at the first one and this one here. Right, it's all we care about. What do you need to multiply by x? What do you need to multiply x by to get negative 13x squared? A negative 13x. Then I'm going to skip this part. I'm just going to do the math, right? I'm going to get this guy and multiply by both of these. Right, so I'm not going to show it again, I'm just going to do it. So negative 13 times x is negative 13x squared. Negative 13x times negative 2 is positive 26. And then we're going to subtract, right? That's the next step. Subtract. Already gone past it. I'll put the little negative sign. I like to personally distribute. You don't have to, but I distribute, so it's a little easier for me. These cancel, and I get negative 10x. Bring down the next term. Negative 4, and then we repeat the process. So it's going to be, look at the x and the negative 10. If you multiply x by to get negative 10, negative 10. Multiply this by both of these, so I get negative 10x plus 20. Right, negative 10 times negative 2. We're going to subtract. I like to distribute, so plus 10x minus 20. These cancel, and I get negative 24 as my remainder. Right, because we went through all this, that's my remainder. And like I said last time, you could write it as remainder, or you could write it like this, 6x squared minus 13x minus 10, and you put your remainder over what we divided by. Now there's a space between those. You could make it a negative 24 over this, or you just put plus negative 24. Either way works, right? So you make that negative down here, or leave it right there. So that's long division. It's the exact same way you did in grade school, just doing a polynomials. The exact same concept. And this next one, just a little key facts. What if like there's missing, it's just like x cubed? Well, you want it to be in descending powers. You want it to go in order, like x cubed, x squared, x1. What if they're not there? You put placeholders with 0 functions. So I think it's best to show you an example. So we'll divide this by this. So 8x cubed, and we're going to put plus 0 x squared plus 0x minus 1. Right, we'll put these placeholders to keep everything in line, make it nice. So it's just like a trick to make the math easier, because that's the way it's supposed to go in order. And then other than that, it's the exact same thing, right? I'm going to look at the first one here. I'm going to do this one a little faster. That's 4x squared, right? 2 times 4 is 8. X times x squared is x cubed. Multiply by both of these, so I get 8x cubed minus 4x squared. Remember, we multiply this by both of them. Then we subtract, put parentheses so you don't mess up. I like to distribute myself. And we add, that becomes 4x squared. Bring down the next one, plus 0x. And again, all we look at is the leading coefficient. That's all we care about. So I'm like, okay, how do I get 2x to be 4x squared? Plus 2x. Then you multiply this 2x by both of these. So 4x squared minus 2x. Subtract. Don't forget the parentheses so you can distribute. These cancel, I get 2x squared, and then bring down that one. And then the last one, what I multiplied 2x by to get 2x squared. Actually, why did I put it squared? There should not be a square there. It should just be 2x. Sorry about that. What I multiplied 2x by to get 2x? 1. So, plus 1. And then when you subtract, again, put parentheses. Oh, these all cancel out. That's my answer. In this case, we have no remainder. Now again, you could get remainders, you could get not remainders. It all depends on the problem itself. But that's the process, right? You do long division like you did in grade school. If they're missing terms, put little placeholders in so you keep everything in line. So that's long division. Now there's a shortcut to this called synthetic division. Now the shortcut only works when it's you're divided by a linear term like we did here, right? These were all linear terms. 2x minus 1, that's a little funky actually. X minus 2. So it only works when it's in this form, like an x minus k. So it doesn't work if you're trying to divide by like 2x squared. So it's called synthetic division. Now this is the way the book shows it. Kind of complicated. I'll show you an easier way, but that is the correct pattern. And the key thing here is when you do synthetic division, you use the opposite of this. So I'll explain in a second, but it only works for x minus k to use the opposite of this. We'll do it a couple times, it'll make sense. So synthetic division, it's just like a shortcut to do this, to do long division. Again, it only works with linear when you're divided by a linear term. So if this was like x squared, I couldn't do it. So we're gonna put these down here. x4. Notice they're missing the x cubed term, so we're gonna add that in. Plus 0x cubed, trying to get me. Minus 10x squared, plus minus 2x plus 4. And then what I generally do is we write the coefficients. Now when you get faster at this, you're gonna skip some steps. That's fine. So we write the coefficients. Notice I leave a space here. I tend to put a little box here at the end. That's gonna be our remainder. And I put an arrow on the first one. So that's my setup. When I do this, right? A little different than theirs. I always start off with the first one, put an arrow, so I know that one should come down. On the last one, put a little box, so I know it's my remainder. Now, we're dividing by x plus 3. We're always going to use the opposite. So you have to use minus 3. It's like inside opposite type of thing. So over here, I'm going to put a minus 3. That's what we're dividing by. Now, here's the rule. That's what they're trying to show up there. You bring down, you multiply across, and then you add down. And then we're going to repeat these process. So that's a process, right? So we're bring down the first one. So this is a 1. We're going to multiply across. 1 times negative 3 is negative 3. We're going to put it right here. And then you just add down. And the key thing is add down. For some reason, everyone wants to subtract. It's the easy operation. You add down. So add down, negative 3. And then we're going to repeat the last 2 steps of the process. We're going to multiply across. So I get 9, right? Negative 3 times negative 3. We're going to add down, negative 1. Multiply across, 3. Add down, 1. Multiply across, negative 3. Add down, 1. And that is our remainder. So here's the key. Here's another key. How do I rewrite it? So the thing is, when you divide by a thing, you lose a power. We're dividing by x, so it should be an x cubed. Look up here. Right, it was x cubed, I divided by an x, I got x squared. Right, it was x cubed divided by an x, you got x squared. You always lose a power when you divide. Well, because you lose a power because you're dividing by x. If I divide by x squared, I lose 2 powers. But like we're dividing by x, we're going to lose a power. So this guy should be x cubed, x squared, x, and then this is our coefficient, and that's our remainder. So I could write this as x cubed minus 3x squared minus x plus 1 with the remainder of 1, sorry. Got a little ahead of myself. So that's good. Or like I said before, you could write it a little fancier. X cubed minus 3x squared minus x plus 1. And then you can always put the remainder over what you divided by. So in this case, I'm going to put plus 1 over x minus 3. So again, a little more proper this way. That has a remainder. Remainders are super important with this stuff, so both ways are fine. So that's synthetic division. We're going to do a lot of this because it's a lot shorter. Right? So it looks a little more complicated, but it's a lot shorter than doing all this. Maybe it's less complicated, who knows. The remainder theorem. The remainder theorem just says that the remainder you get is the exact, if you just wanted the remainder, there's a shortcut to find the remainder. Like this is already a shortcut, but there's even a faster way just to get the remainder, if that's all you cared about. And that is, instead of doing synthetic division with the negative 3, you just plug it into the function. That's the remainder theorem. So if I just get the negative 3 here, right? Remember, if it's x plus 3, I use opposite. If I just plug negative 3 into here, if I substitute it in, I'm going to get 1. That's what the remainder theorem says. So let's try it real quick. Right, again, I'm going to plug this into the original. So we're going to do negative 3 to the 4th minus 10 times negative 3 squared. Now if you have a calculator, it's even faster. Plus 4, so I'm going to get 81. You do this first, that's 9, so minus 90. And let's see, so we can see them work a little bit. Multiply these two, that's positive 6. Plus 4. Okay, let's do it 2 at a time. That's negative 9. 6 plus 4 is plus 10. 9 plus 10 is 1. So the exact same thing. So that's the remainder theorem. That if you just want the remainder, which is actually really important in polynomials, if you just want the remainder, you could do synthetic division and get the answer, or long division technically. But the shortcut is just plug in the thing you would use for synthetic division, right? So if it's like this, opposite, negative 3. If it's a negative, make it a positive. Plug it into the equation, substitute it into the equation, and then whatever you get, that's the same thing as a remainder. So that's remainder theorem. It's like a visual aid would be like if you're doing this, let's say this is a, so it's x minus a, right? So you do that. My remainder right here. The remainder equals f of a. So that's what the remainder theorem says. So let's do this one. Use the remainder theorem to evaluate the following function. X equals negative 2. So this one's saying, so we're using the opposite way actually. Like, so a lot of times it's like, what if you don't want to plug it all in? That takes forever. Sometimes it does. Instead of plugging it all in, you can just do synthetic division to get your answer. So whichever way you like better, right? So sometimes it kind of sucks to do this. So this is a lot easier, and vice versa. So that's what we're gonna do here. So we're gonna do synthetic division to practice our synthetic division. Now, if we're using a remainder, we just use the value. We don't have to switch it. You only switch it when it's like x plus a, or right, that would be negative a, or x minus b. You use positive b. But if I just give you it, just use it. So synthetic division, this will be 3, 8, 5, negative 7. The last one is our remainder. So the rule is bring the first one down, 3, multiply across, negative 6, add down, it's the easy one, 2, multiply across, negative 4, add down, 1, multiply across, negative 2, and then add down, negative 9. So our answer is negative 9. If I would have just plugged in negative 2 into our equation, we would have got negative 9. Right? So if you didn't want to like plug negative 2 into all that, it's like if you didn't have a calculator, so that might be harder. Just do synthetic division. The factor theorem. So for the factor theorem, first step is, what's a factor? So if I asked you what the factors of 10 were, well, I hope you would say the factors are 1, 2, and 5. Do you remember why those are factors? Like, why are they called factors? It's because when you divide by those numbers, you get no remainder. That's what makes something a factor. It's when you divide by it and your remainder is 0. That's what makes it a factor, right? Like 3 is not a factor of 10 because when you divide, you don't get a remainder of 0. That's all the factor theorem is saying is, hey, if you divide by x plus 3 and you happen to get a 0, we got a 1, so it's not a factor. This is not a factor. But if you get a 0, that guy's a factor. So that's the factor theorem. That's what this is saying, right? If you divide by x minus k, and you get a remainder here of 0, or you plug it in, and you get equal to 0, then that means that this guy is a factor. So that's what it is. Just like when you divide normally. Factor is when you divide and you get a remainder of 0. That's all it is. So here, show that x minus 2 and x plus 3 are factors of this, and then find the remaining factors. Well, what's going to happen here, since I know these are factors, that means when I divide, it's going to get a remainder of 0. So if I do synthetic division on this guy, let's do this to make it easier. That's not what I wanted. So let's say 2, 7, negative 4, negative 27, and negative 18. Right? My remainder here should be 0 because it's a factor. You can use any one you want first. Let's go in order. So remember, if it's a negative 2, I gotta use a positive 2 here. Bring the first one down. So I start with the 2. We're gonna multiply across. 4, add down 11, multiply across 22, add down 18. It looks big, but trust me, it's gonna work. Multiply across, I get 36. Negative 27 plus 36 is negative 9. Positive 9, sorry. 36 is bigger, so it's positive. Multiply, and I get 18. And I get 0. Boom. Right? So that was a factor that worked out perfectly. Now, here's the thing. Remember, we went down a level. So this is x cubed plus x squared plus x minus 9. If I was going to rewrite this, it'll be like this. Right? But they want I have another factor here. So we're just going to do it again. So let's do synthetic division one more time. That's too big of a box. I don't need that big. Something like that, right? My last one here should be a remainder. Bring the first one down. This time, we're going to use x plus 3, so it's going to be a negative 3. Remember, when it's in this form, always use opposite. So bring the first one down. This is 2. Multiply across, negative 6. Add down, I get 5. Right, multiply, then add down. Multiply, negative 15. Add down, 3. Multiply, negative 9. Add down, I get 0. Right, so again, worked out of another factor. Now remember, this is always 1 power less. We started at x3 now, right? Because we didn't reset, we just used my answer to go down again. So now this should be x cubed. This would be x squared, this would be x. So we have this, 2x to the 5th squared plus 5x plus 3. I don't know why I said to the 5th. So that's our function. Now, normally I would be done, right? I have my 2 factors, like I showed their factors, but then it said find the remaining factors. How do I do that? You just factor it. So a little practice if you haven't done this in a while, right? You multiply top first 2, and I get 6. Put the middle one down here. Think of all the things that multiply to get 6, but add to get 5. So I'm going to do like 1 and 6, 2 and 3, 2 and 3. Now the tricky thing is, remember, if there's a number in front, we have here, you have to divide by the number in front. So I get 1, and I get 3 over 2. So we rewrite it, x plus 1. And remember, bottom goes front, so 2x plus 3. So those are the remaining factors. So that's how we use it. Okay, so got a lot more to go. Use remainder theorem with synthetic division. We did that, right? All the things, keep in mind it's a factor. It's also an x-intercept. If you get a 0, like, it means all these things. It means it's an x-intercept. Like, that's why zeros are so important. So this is if, like, remainder equals 0. It is super duper important. That means, like, the thing you plugged in, x minus k, or f of k, they're an x-intercept, they're a factor, they're a 0. So remember we talked about those? Finding 0 is super important. You could factor things, you could solve things, it's a big deal. And we're going to show you by finding the rational 0 test. So first, what's a rational number? Remember, a rational number is any number that can be written as a fraction. Like a over b. So like 2/3 or 3, because 3 is 3 over 1. Right? So what's not a rational number? Stuff like radical 3 or pi. So these are not rational. Rational is any number that you could write as a fraction. So those are, we like those numbers. So this is the way to find the rational zeros of a polynomial function. We're not going to be able to find those. We'll talk about how to find those later, but you can find the rational zeros by doing something like this. And what the trick is the possible rational zeros, the possible real rational zeros of a polynomial function are just, I like to say, last over first. So that you see a lot of p over q. All this means is q is the last term, like the constant term, and p is a leading coefficient. So like here it says constant term over leading coefficient. I always just say last over first. So if you want to find the possible rational zeros, we're gonna do the factors of the last one over the factors of the first one. And those will give us the possible rational zeros. So here, find all the rational zeros of this guy. So we're going to do last over first. So my last one is 1, over my first one is also 1, because it's cubed, 1 in front. Now what we got to do is do all the factors of it. Now factors of 1 is easy. It's just plus and minus 1 and plus and minus 1. We always have to do plus and minus. So our choices are, right, positive 1 over 1, which would be 1, or negative 1 over 1, which is negative 1. Now, how do I find out which of these are 0? Well, we're going to do synthetic division. Test with synthetic division. So we have x cubed plus 0x squared. You're not going to get me, book. I see you. X plus 1. So 1, 0, 1, 1. And then we just try one out. There's no shortcut to this. You've got to pick one. Do you want to try plus or minus 1? No, there's no right or wrong answer. Let's try positive 1. So plus 1. Remember, we bring the first one down, you get a 1. Then we multiply across. We get a 1. Add down 1. Multiply across 1. Add down 2. Multiply across 2. Add down 3. Notice this is not 0. Right? So we failed. This is not a factor. We only care about getting a 0. So positive 1 is not a factor. So I'm going to erase. I'm going to try negative 1. That should work. Right, because all we care about is getting a 0. So that's a negative 1 now. Always bring the first one down. Multiply across, that's 0. Add down is 0. It helps if I can multiply. Multiply across, that's negative 1. Sorry. Add down is negative 1. Multiply across, I get 1. So I get 2. Multiply across, I get negative 2. And I get negative 1. So also not a 0. So also not a factor. So this has no rational factors. That's kind of not my favorite. No rational zeros. That kind of was not my favorite example, but it shows you sometimes you get no rational factors, and you have to get a 0. In both cases, I didn't get a 0. Okay, last one. So we're going to find all the rational zeros of this one using rational root tests. So first we got step 1 to find the possible roots. So that's what we're going to do last order first. So last order first, we're going to do the factors of 3 over the factors of 2, right? The last term over the first term. Now remember, I need the factors of 3. So what things multiply to get 3? So 1 and 3. And the things that multiply to get 2 are 1 and 2. Now here's the kind of crappy part. You got to do all the combinations. So like 1 over 1, 1 over 2. So plus or minus 1, plus or minus 1 half. Right, so 1 over 1 is 1, 1 over 2 is 1 half. Then we're going to do the same with 3. Plus or minus 3 and plus or minus 3 halves. So those are the possible rational roots. You might go like, oh, that's a lot of work. But think about it. This is actually super powerful. Of all the numbers in the world, 2 billion, 335, 6. Only ones that could possibly be a zero of this are these 8 choices here. Now this should have about 3 zeros max. It might have 0. It might have 0 rationals like the last one. But it can only have 3 zeros max. And it comes from here. So it's either this or it's none. Right? So it's actually super powerful because I know it's not going to be 5. I know it's not going to be 2. Right? So it could either be this or it could be none. Like none rational. So step 1, list possible rational roots. Step 2, I would do, if you have a graphing calculator, I would say graph to see which to try. So if you have a graphing calculator, graph this thing, see which ones like might work. Let's see if it crosses that one. Maybe one will work. If not, try to find a 0. Back when I was in school, I'm an old guy, right? You didn't have a graphing calculator. Well, you had one, but they didn't let you use it. You just had to keep on plugging until you got. And by it, I mean a 0 at the end, right? A remainder of 0. But let's pretend we have a graphing calculator. How it looks like. So if I graph it on a calculator, it looks like this. Looks like this. Took a little screenshot. Right, so this is how I was looking at a graphing calculator. Now look at this. It looks like it crosses maybe at -3, maybe at 1, right? So like it doesn't, I don't see 3, maybe at 1. Like maybe 3 halves, but like I know it's not -3 halves. I know it's not +3 because that doesn't go over there, right? So let's try 1. I think 1 would work. But this is how you use a calculator to tell. You look where it crosses and look at what you have and see where it matches up. So I think 1 will work. So we're going to do synthetic division. So our use the coefficients 2, 3, -8, 3 on a remainder. We want 0. Bring the first one down. And let's use 1 because it looks like it crossed that 1. So bring the first one down, multiply across, add down, multiply across, add down. Why did I put a negative? There we go. -3. So right, 5 times 1 is just 5, then you add down. -3 and then multiply. -3 and I get a 0. Woo! Right, so we get that. So that's 1, 0. So one of our zeros, is 1. And we got to find all the zeros. We got to find 2 more. Right, there should be up to 3. So what do you do after you find a 0? You repeat until you get to x squared. So you gotta do it again. So now we're lucky. We started at x cubed, right? This was x cubed, so that means we're 1 lower at x squared. We're gonna set this equal to 0 because that's what we're trying to solve. So we're already at x squared. So it's like if this was x to the 4th, you have to do this a couple of times so you get down to x squared. And why do we go down to x squared? It's because then you just solve x squared. We know how to solve that. You either factor or you use a quadratic formula or complete the square. Right? So we know how to solve an x squared. We can't solve an x cubed easily, but we can solve an x squared easily. This one I think is factorable. So write big O x, multiply these together, -6, put a 5 on the bottom. We're going to divide these by 2. What are 2 things that multiply to get -6 but add to get 5? So keep in mind it's a -6, so it's a -1 and 6, -6 and 1, -2 and 3, -3 and 2. And it would be -1 and 6. Nothing reduces here, so it's going to be 2x, don't forget bottom goes first, -1, and 2x plus 5 equals 0. And we still got to solve it, so split and solve. And then solve it here, so 2x equals 1, x equals 1/2. 2x equals negative 5, x equals negative 5/2. So there are 3 zeros. And that's the lesson.